Hello, this is Sal. This video is about configuring ASA basic settings and firewall using command line interface. We have here the company has one location connected to an ISP. Router 1 represent a CPE device managed by the ISP. Router 2 represent an intermediate internet router, and router 3 represent an ISP that connects an admin from a network management company who has been hired to remotely manage our network. The ASA is an edge CPE security device that connects the internal corporate network and DMZ to the ISP, while providing NAT and DHCP services to inside hosts. The ASA will be configured for management by an admin on the internal network and by the remote admin. Layer 3 VLAN interface provide access to the three areas created in the activity: inside, outside, and the DMZ. The ISP assigned a public IP address space of 209.165.200.224/29, which will be used for address translation on the ASA. Now, let's determine the ASA version, interfaces, and license. Command line. Let's type the command show version, and we'll maximize this. This will show us various aspects of the ASA device. This will show us the software version, which is 8.4, and the amount of RAM, which is 512 megabyte RAM, and will show us the maximum. It's showing us lots of things, but important stuff, that 8 physical interfaces, and it supports only the 3 VLANs, because what we have here is the base license. Now we will configure the host name and the domain name. Enable, no password, configured yet, just hit enter. Host name, ASA, configure terminal, host name, ASA, domain name, CCNA Security.com, and we'll configure the enable password of Cisco. Enable password Cisco. Now let's configure the inside and outside interfaces. Enter VLAN 1, name of the interface, inside, IP address of 192.168.1.1, subnet mask of 255.255.255.0, and security level for the inside VLAN. VLAN number 1 would be the highest of number 100. Now let's do the VLAN 2. Enter VLAN 2. Name of the interface, name F, outside, IP address 209.165.200.226, which is this side. Subnet mask 255.255.255.248, and the security level of 0. Now let us check the configuration on the ASA so far. we will use the command show interface IP brief. Show interface IP brief, showing us the VLAN, VLAN 1, VLAN 2 with the IP addresses here, and the ports are up and up. This command is different from the iOS command, which is show IP interface brief. On a side note, most of the ASA show command, including ping, copy, and others, can be issued from within any configuration mode prompt without the do command. Now, let us use the show IP address. Show IP address here, it's gonna show us the information for the layer 3 VLAN interfaces. Another command, which is show switch VLAN. Here it will display the inside and outside VLANs configured on the ASA and to display the assigned ports. Now we should be able to ping from PCB to the ASA inside interface 192.168.1.1. We'll be able to ping this side, but not this side of the ASA. Ping 192.168.1.1. We receive the reply, but we will not be able to ping this side yet. Now we will be configuring routing, address translation, and inspection policy using command line interface. I will configure a default static route on the ASA outside interface here to enable the ASA to reach external network. I will create a quad 0 default route using the route command associated with ASA outside interface and point it to router 1. This side of router 1, G000, and the IP address of 209.165.200.225, this side. This will be the gateway of last resort for the ASA. Route, and we want to route outside 0.0, and we want to point it to this side of this interface of router 1. IP address of 209.165.200.225. Enter. Now let us issue the command show route to verify the static default route in the ASA routing table. Show route, and showing us the static route. Now I will verify that the ASA can ping router 1, this side, which is interface as 010. Ping 10.1.1.1, and it was successful. Now let's work in configuring address translation using path and network objects. Now object, and our only option is network, and we will name it inside net. Let's see, here we have subnet 192.168.1.0 with a subnet mask 255.255.255.0. NAT. We want to NAT inside to outside. And we want to use dynamic and on the interface. And now let us ping from PCB this guy here, router 1 gig 000 209.165.200.225. Let's see. Ping 209.165.200.225. Let's issue the ping again. 209.165.200.225. And this should fail. Now let us issue the command show NAT to see the translated and untranslated hits. So we issued this command. We pinged from PCB to the outside interface and this side of router 1. We suspected that it will fail, and let's go to issue the command show NAT, and here it's gonna show us that the translated hits were 8, untranslated, here we notice that the pings from PCB 4 were translated, but in this case there were 8 were translated. The routing ping echoes were translated and sent to the destination. The returning echoes replies were blocked by the firewall policy, but we will configure the default inspection policy to allow the ICMP, which is ping. Here we see that we sent 8, and even if we send another ping, it will fail until we configure the inspection policy. Now, I will modify the default MPF modular policy framework. Packet tracer does not have an MPF policy map in place by default. As a modification, we can create the default policy map that will perform the inspection on inside to outside traffic. When we configure it, only traffic initiated from the inside is allowed back into the outside interface. We will need to add ICMP to the inspection list. I will create the class map and I'll call it inspection default. Policy map, I'll call it the global policy and service map. And then add the inspection of ICMP traffic to the policy map list using the following command. First, empty class map. We will name it inspection underscore default match. We want it to match the default inspection traffic. Exit. Now policy map, we'll call it global policy. Class, the class we created, inspection. underscore default, and we wanted to inspect the ICMP for now. Now we configured it, exit, service policy, global underscore policy, and we want it global. Now we configured it. Let's see that on PCB, from here I will ping router 1, this side G00, this IP address 209.165.200.225, and see ping 209.165.200.225, and we receive the ping should be successful, and it was successful. And again, the ICMP traffic now is being inspected and legitimate return traffic is being allowed. Now, let us configure the DHCP address pool and enable it on the ASA inside interface, which is this side of the ASA VLAN 1. DHCP. Now I will configure a DHCP address pool and enable it on the ASA inside interface. 192.168.1.5, 192.168.1.36, and we want this inside. Optionally, we can specify the IP address of the DNS server to be given to clients. DHCPD DNS 209.165.201.2 interface inside. Now I will enable the DHCP within the ASA to listen for the DHCP client requests on the enable interface and inside. DHCP enable and enable it inside. Let us now change the PCB from a static IP address to use the DHCP, and it was given the IP address of 1.5. And we will verify that again by issuing the command IP config. And it was given the IP of 192.168.1.5, and the gateway is pointing to this side of the ASA. Now I will configure a AAA to use the local database for authentication. I'll create a user named admin and specify a password of admin. Username admin, password admin. Now I'll configure AAA to use the local ASA database for SSH user authentication. AAA authentication, SSH console local. Now it's time configuring remote access to the ASA. The ASA can be configured to accept connections from a single host or a range of hosts on the inside or outside network. Here, hosts from the outside network can only use SSH to communicate with the ASA. SSH sessions can be used to access the ASA from the inside network, from here and from the outside. First, I will generate the Rsa Key Pair, which is required to support SSH connections. Because the ASA device has RSA keys already in place, I will enter no when prompted to replace them. Crypto key generate RSA modulus 1024, and I will enter no. Now I will configure the ASA to allow SSH connections from any host on the inside network, which is 192.168.1.0, this network, and from a remote admin in this side on PCC with the address of and the network of 172.16.3.1. But the host here, we have it configured with the IP address of 172.116.3.3. Now SSH 192.168.1.0 for the inside network with the subnet mask of 255.255.255.0, and this is inside. SSH for the outside 172.16.3.3. That's one host, which is PCC on the outside, our outside network admin. A subnet mask of 255.255.255.255 outside. Enter. Now let us establish an SSH connections from PCC, the branch office here, to the ASA on this side of the ASA 209.165.200.226, this side. SSH link admin 209.165.200.226 admin enable Cisco. So it was successful. Now let us try to establish a session from PCB, from the inside network. SSH link admin space 192.168.1.1 password of admin enable of Cisco, and this was successful. Now we will configure the DMZ here, static NAT and ACLs. Router 1 on this side, G000, and the ASA on the this port, E00, already using 209.165 and this range of the network 200.225 5 for router 1 and 26 for the ASA. We will use public IP address of 209.168.200.227 and a static NAT to provide address translation to the server. Now, let us configure the DMZ interface VLAN 3 on the ASA, which is where the public access web server, the DMZ server, here will reside. I will assign to the server an IP address of 192.168.2.1 with subnet mask of 24, name it DMZ, and assign it security level of 70, because the server does not need to initiate communication with the inside users. I will also disable forwarding to interface VLAN 1. This is how we will make sure that the inside network is completely secured. Enter VLAN 3 IP address of 192.168.2.1, subnet mask of 255.255.255.0. No forward to interface VLAN 1. Name of this interface, we'll name it DMZ, and the security level of 70. Now, I will assign ASA physical interface E02 to DMZ VLAN 3 and enable the interface. Now, interface E02, this interface here, switch port access VLAN 3. Let us use the show interface IP brief to display the status for all ASA interfaces. Show interface IP brief. Showing us the 3 VLANs. Ports are up and up. Now let us use the command show switch VLAN to display the inside and outside VLANs configured on the ASA and to display the assigned ports. Here we have for the DMZ, which is the port 02, this side, and for the outside, the E00, and the rest of the ports are with the inside network. Now it's time to configure static NAT to the DMZ server using a network object. I will configure a network object named DMZ server and assign it static IP address of the DMZ server, which is 192.168.2.3, and while in definition mode, I will use NAT command to specify that this object is used to translate a DMZ address to an outside address using static NAT and specify a public translated address of 209.165.200.227. Object, network, DMZ, server. Host, which is the DMZ server, the IP address of 192.168.2.3, NAT, DMZ, outside space static 209.165.200.227. Now I'll create a named access list. I'll call it outside DMZ that permits the TCP protocols on port 80 from any external host to the internal IP address of the DMZ server. And then I'll apply the access list to the ASA outside interface in the in direction. Configure terminal, access list, configure, exit, access list. Sorry about that. We will call it outside is DMZ. We want to permit ICMP any to host 192.168.2.3 access list with the name outside DMZ permit. We want to permit TCP from any host 192.168.2.3 equal 80, port 80. Now access group outside DMZ in interface outside. So we are done with the access list. Let us notice that unlike iOS access list, the ASA access list permit statement must permit access to the internal private DMZ address. External hosts access the server using its public static NAT address. The ASA translates it to the internal host IP address and then applies the access control list. This is for today. Thanks for watching. I hope you found it helpful and informative. See you next video. Thank you very much for watching.